In section 4 of module 4, we're going to do a little matching. So let's raise it up, and it says we're going to assume that A and B are both greater than 0. So there's no negative numbers under the radical sign. So let's just get it right up there. And let's see here. We can get you just a little bit more there. And we'll give you your assignments. There we go. 1 through 8. And I believe they're only used once. We'll pause. Now, hopefully I gave you the hint that you should try to work these out and then match them up, because if you don't work them out, then it's very difficult to match them up. So take a moment, see how you've done, and check it out. We'll give you a moment. In fact, let's just go over some of these here. So notice we said you could take your index number, divide it into the exponent, and that gives you b to the third here in the denominator. And there is no perfect third up there, so that's just the third root of a to the second. And here you can divide this, and this becomes b to the third, a to the second, so very simply. And I thought number 7 looked a little tricky. Notice, to rationalize this denominator, you have to multiply it by the fifth root of b to the second, and in the top, the fifth root of b to the second. Remember, this is a 1, which we are allowed. So this now becomes the fifth root of b to the fifth, which is right here. This is not simplified yet, because this denominator will just end up being b. In a sense, we've rationalized our denominator here. And here, you can't group these because they're not the same things. Okay. Again, if anyone has any questions on any of these, I'll pause again, and you can ask me those. Now what we'll do is we'll go through examples 9 through, let's say, 24. Give some assignments, and you want to simplify these. So the example you get, write it down and simplify it. As I did some of these, very easy the first few. But then they started to get a little more challenging after number 14. So here we took the square root of 36, got 6, divided y to the third into y to the second, which comes out as y, and what is left is a square root of y. This is a perfect square, so you take 4 divided by 2, get x to the second. So this was very similar. Square root of 25 is 5. A to the fourth, which is a to the second, and then square root of a left over. And this is a perfect square. And here, 27 is a perfect cube, that's 3. A to the third is a perfect cube, that comes out as a, and you're left with the third root of a. Now this is a perfect cube. Cube root of 8 is 2. cube root of b to the third is b. Then I went down to this one and I said, ooh, they're starting to get complicated. So showing you how to do it may be the better thing. So what we're doing is, again, we're putting two sets of radical signs. And under one radical sign, we're looking for factors of 32 that are a perfect fourth, and that's 16. So I put the 16 there, and a to the fourth is a perfect fourth, so I put that there. And then what do you have left? Well, there's a 2 that I'll put there. Now I'm going to put in the denominator, again, under the radical sign of the fourth root, things that are perfect fourths. And that's what we see here. So notice the 2 is not a perfect fourth, so we had to put that in its separate radical sign. But now notice this just cancels out. This is a 1. So that goes away. And now we just have perfect fourths left here, which will be 2a on the top here. And on the bottom we'll have b and c to the second, because c to the eighth can be divided by 4, which gives us c to the second. Well, that's basically how all these are done, and I want to keep this short, so that's where we'll stop.